In the following video series, we're going to examine how to solve exponential equations and inequalities. Now, before we do this, we have to learn how to simplify exponential expressions. And so we need to remember our rules of exponents. When do you add exponents? And you add exponents if I have the example, let's say x squared times x cubed. You know that's going to be x to the fifth. And so we add exponents when you multiply like bases. And now we look at when do you multiply exponents. So again, if I were to use, let's say, x squared, and I were to raise x squared to the third power, that would give me x to the sixth, 2 times 3. And so we multiply exponents when we are taking a power to a power. And so what we need to get from this video is the idea of remembering all of our properties of exponents, which the ones that we have are our product rule, our quotient rule, and our power rule. The product rule says that if you are multiplying like bases, you add the exponents. The quotient rule says that if you're dividing like bases, you subtract the exponents. And the power rule states if you're taking the power of a power, you multiply the exponents. And so these are our properties of exponents that we're going to use to simplify our expressions. So let's apply them in the following examples. If I have 7 to the radical 2 power times 7 to the radical 3 power, it doesn't matter that there's radicals in the exponents. I am multiplying the same base. So what do? I add my exponents, radical 2 plus radical 3. And you can't go any further. They're not the same radical. Don't have the same radicand, so we can't combine them together. And so that is my final answer, 7 to the radical 2 plus radical 3 power. If I am taking the power of a power, it doesn't matter that they are radicals. I still am going to multiply the exponents together. So radical 3 times radical 5 is radical 15. So you have 8 to the radical 15 power. And you can't simplify the radical 15 power. And so that's your answer. And so we see, though we're working with radicals and the exponents, the properties of exponents still hold to be true. You're multiplying like bases, you add exponents. If you're taking the power of power, you multiply them. Just we need to make sure we check to see if they can be simplified. So if I take a look, I have 5 to the radical 3 power times 5 to the radical 27 power. Now, what should stand out right away is, yeah, I'm going to add my exponents together because really I have the same base. So I have 5 to the radical 3 plus radical 27. And so if I'm going to simplify this, I need to see, can I simplify these together? And what should stand out is that the square root of 27 can be simplified. I mean, it's 9 times 3, which 9 breaks into 3 and 3. So the square root of 27 is really 3 radical 3. And so my expression really is 5 to the radical 3 power plus my 3 radical 3. So they do have the same radicand. I have 1 radical 3 plus 3 radical 3, which is 4 radical 3 for my exponent. So 5 to the 4 radical 3 power. You need to remember, whenever you're dealing with radicals, you have to check to see if they can be simplified. And so square root of 27 is really 3 radical 3, and so now I have the same term of radical 3. I can add them together. If I have 2 to the radical 2 power being raised to the radical 8 power, this is the power of power, so you multiply them together. 2 times 8 is 16. So I have 2 to the square root of 16 power. Well, the square root of 16 is 4. And so really I have 2 to the 4th power. And 2 to the 4th power is 16. And so we had to check, can our radical be simplified? If it can, we have to perform that simplification and then make sure we can get the answer from there. So here's an interesting one. 2 times 3 radical 2 times 3 to the negative radical 2. Well, the ones that have the same base are here. So this 2, I'm just going to leave alone right now. I am going to multiply my like bases, which means I'm going to add the exponents. So if I add the exponents, I have 3 to the radical 2 power plus a negative radical 2. Well, any number plus its negative is really 0. And so I have 3 to the 0 power. Anything to the 0 power is 1. And so I'm left with 2 times 1, which is just 2. And so if you look at the way these examples are broken down, the first 2 examples that we worked with didn't have any simplification with the radicals. You could not simplify them, so you left them alone. The last 3 examples we did, we always had to go through and check. Can we simplify radical 27? Yes, we can. Can we simplify radical 16? Yes, we can. Can I add these together? Yes, I can. So we did examples following both where you can combine like terms and simplify when you can't. So you always need to remember to check if your radicals are completely simplified before you stop with the final answer.